This short video will look at a couple more examples of covalent bonds or covalent compounds. Covalent compounds, recall, are between nonmetals only, and we're going to use our idea of Lewis dot structures to write down the number of Lewis dots, the number of boxes that need to be filled, and then we're going to figure out the Joseph-Proust definite proportions from the number of boxes that you have lead into the number of bonds that you have to form. Hydrogen has one dot and one box. That's why we lump it over with the with the group 1 metals, not the noble anything, with the group 1 metals. Although it's a non-metal, it's lumped with the alkali metals because it similarly has one dot. Hydrogen has one box, so it can form one bond. Nitrogen has 5 dots, but it has 3 boxes, so nitrogen can form 3 bonds. Well, if you can form 3 bonds, bonds to what? Well, I need 3 hydrogens to form bonds to hydrogen. We don't have ions in covalent compounds. We don't exchange electrons, we share instead. So I would have nitrogen and 3 hydrogens. My nitrogen now has eight electrons around it. Remember from a previous video that you typically have these boxes located between the atoms. So if I have 3 multiplied by 1, that's 3 boxes, plus another 3 boxes here, then that's 6 boxes total, and they're between the atoms. I have 3 dots plus 5, that's 8 dots total, so I have 8 dots on this side as well. We can write these bonding pairs as lines. So I can write NH3 if I like, and I can show my 1 to 3 Joseph-Proust definite proportion, or I can have my 3 bonds like this. Where bonding electrons become a line or a covalent bond, and my lone pair electrons that don't have an atom appear are just left as a lone pair. To conclude this video, let's look at hydrogen and carbon. Hydrogen with its dot in its box. Carbon is going to have 4 dots and 4 boxes. Hydrogen can form 1 bond, but carbon needs 4 bonds. So we need 4 hydrogens for our carbon atom. So I can write my carbon in the center, I can surround it with its 4 hydrogen. And I know that the boxes are going to be between the atoms. So I can write box, 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 box. Fill that with my electrons. Boxes must always have electrons in a covalent compound. So I've got 4 dots and 4 dots, so I should have 8 dots total. Check. I have 4 boxes here plus 4 boxes here. I should have 8 boxes total. Check. I could just abbreviate that as CH4, or I could write C with my bonds. Okay, I have a 1 to 4 definite proportion. And this concludes the video.